So let me discuss first the theory on plane trusses. So we define a truss as an assembly of straight members assumed to be pin connected at their ends. So these pins are, of course, frictionless. A truss member is a two-force body, therefore its bar is an unknown. So if we have here a truss member, then we always assume the stress in that member to be in tension. So therefore, the unknown is the bar force or the stress of this member. And we always assume the member to be in tension. So the stress in the member of the truss is either tension or compression. In the process of analysis, each member is always assumed to be in tension, and then negative sign of the force corresponds to compression. So classification of trusses. Trusses are classified as simple, compound, or complex. Simple trusses are those that start with a simple frame-like shape or frame truss like this. So if we extend this truss, all you have to do is add two members and introduce another joint. So let us say two members added, then another joint, two members added, another joint, two members added, another joint, and so on and so forth until such time that you end. So let us say let's end here, then you put the support to be stable, ruler support to be determinate, then this truss is still classified as simple. While when two or more simple trusses are joined together by joining them to their common joint and adding one additional bar, or joining them with to three joints and adding three members, then the truss is called compound. So it is a combination of two or more simple trusses. Like this one, we have a simple truss, another simple truss, and they are combined by meeting them to their common joint and adding one additional bar. Another compound truss is this. We have a simple truss, triangular truss here, and another triangular truss here. Then the two trusses are combined or joined by adding three bars. So that's it. That's the principle for compound truss. While for a complex truss is one that cannot be classified as either simple or compound, like the one shown. So take note that this is not a joint. This is not a joint. The members are just passing side by side. So that's not a joint. So this is only one member, one member, one member. And for this truss to be stable, A should not be equal to B for stability. Because when A is equal to B, this becomes unstable. And that is only manifested by computing the stresses, which will give inconsistent results. Then another example of a complex truss is this. So this is also a complex truss. So these are not joints. Then to facilitate the analysis of trusses, there's a need to identify zero force members. These members do not carry any force, but we cannot omit them or remove them from the truss system because they help in the geometric stability of trusses. So remember the criteria for or criterion for stability of trusses. So there are two cases only to identify them. Case one, if there are two forces that are not collinear, then its force is zero. So for instance, in this truss here, so that's one force, this is another force. So there are only two forces and they are not collinear, therefore H is 0. So the proof is if you sum up forces vertical component of this force plus nothing equals 0. So therefore this is 0. Then if this is 0, summation force is horizontal, then the other member is also 0. So it's easy to locate when there are two members meeting at an unloaded joint and they are not collinear, then the two members are zero force members. So for case 2, if all but one meet at an unloaded joint, two of which are collinear, the member not parallel to the collinear members is a zero force member. Or the member that is whose line of action is unique carries no force. So this is the situation I'm referring to this case 2 here. So if these two are collinear, therefore this member is unique. If you concentrate on this joint here, summation forces vertical is 0, then obviously this is 0 because that's already vertical, then you have nothing to add because this is unloaded. So that's why it is 0. It is a 0 force member. Then for the method of analysis, we have method of joints applied to joints where when there are only two unknown members for a 2D truss or three unknown members for a 3D truss. Then we have the method of sections. We section members such that all but one has a unique line of action. The member with the unique line of action is determined by summing up moments on the point of currency of the other section members. Members considering the portion which is simpler. Then the third one, which is specially uh, employed for complex trusses, is the method of substitute member. So I will just demonstrate this to complex truss in one of our examples.